All right, let's get right into it. We all know AI is everywhere, and it's getting smarter by the second. But what if the next giant leap for AI isn't just a better algorithm, but a totally new kind of network? Today, we're diving into a vision for 6G. And no, this isn't just about faster downloads. We're talking about a mobile network built from the ground up to power a new generation of intelligent, privacy-first AI.
And that really brings us to the one massive question that sits at the heart of this entire explainer. How do we feed AI's incredible appetite for data, all that personal stuff on our phones that makes it so useful, without completely giving up our privacy? Is it even possible for AI to get smarter from our data without ever actually seeing our data?
You know, this fundamental tension, this conflict between AI's thirst for data and our deep need for privacy, well, it actually has a name. It's called the AI privacy paradox.
Okay, so here's the deal. The more personal data an AI model gets from our photos, our messages, our health apps, the better and more accurate it becomes. But the old way of doing things, just scooping up all that sensitive data from everyone's phones and shipping it to one central server in the cloud, that is a recipe for disaster. It's inefficient, it's slow, and it creates this giant, glowing target for data breaches. We have to find a better way.
So how do we get around this problem? Well, a couple of really clever compromises have popped up to try and fix this. Let's take a look at the two big ones you might have heard of: federated learning and split learning.
First up is federated learning, or FL. Honestly, the best way to think about this is like a potluck dinner. Your phone cooks a little part of the AI recipe using only the ingredients it has locally. That's your data. But here's the key. It never shares those ingredients. Instead, it just brings its small finished dish, the model updates or the learnings, to the party. The central server then combines everyone's dishes to create one big improved final meal. And this whole process is a continuous loop. The server sends the main AI model down to your phone then trains that model using your local data, and here's the magic part. Your device sends only the changes, only the learnings, back up to the server. The server then aggregates all those updates, creates an improved global model, and the whole cycle starts over again. Your raw data never ever leaves your phone.
The other approach is split learning, or SL. Now, this is more like a secure assembly line. A deep neural network is really just a series of computational layers. SL cuts that model right in the middle. Your phone does the first few steps of the calculation, processing your raw data into this intermediate kind of scrambled result. It then sends this semi-finished anonymous blob over to the server, which completes the rest of the assembly line. The server never sees the raw materials, only the product that's already halfway built.
But of course, this leads to a pretty big trade-off. FL is awesome because everyone can train at once, but it can be slow to improve, and a really determined attacker could potentially reverse engineer your data from the model updates over time. On the other hand, SL offers even better privacy because nobody ever sees the whole model, but it's sequential. It has to process one device at a time, which can create a major traffic jam. So yeah, neither one is perfect.
So if both methods have their own problems, what's the answer? Well, this is where the research gets really cool. It proposes a new, super flexible approach that aims to give us the best of both worlds.
The big idea here is just brilliant in its simplicity. Instead of thinking about federated and split learning as two totally separate, rigid methods, what if we just saw them as points on a spectrum? A spectrum that we can control simply by deciding where to make a cut in the AI model.
Let's walk through this. For instance, what if we place that cut at the very bottom, before the first layer of the model even starts? Well, that means your phone does zero work, and all your raw data gets sent directly to the server. That's just the old-school, traditional way of doing things, centralized learning with no on-device privacy.
Now, let's go to the other extreme. What if we place that cut at the absolute top, after the very last layer? In that case, the entire model runs on your device. Your phone does all the heavy lifting and only sends the final updates back to the server. And what does that sound like? Yep, that's just federated learning.
And finally, you can probably guess this one. If we place the cut somewhere in the middle, splitting the computational layers between your phone and the server, well, that's exactly what split learning does. So this single concept of a movable cut unifies all of these approaches into one single, elegant framework. Pretty cool, right?
Okay,
Having a cool framework is one thing, but how do you actually build a network that can manage all of this dynamic cutting and slicing? That's where the proposed 6G architecture, called NET4AI, comes in.
This quote from the paper really gets to the heart of the vision. It says 6G will go beyond connectivity provisioning to enable connected intelligence. And that is a huge shift in thinking. We're not just talking about a faster pipe for your videos. We're talking about the network itself becoming an active participant in computing, a platform for intelligence.
So to do this, NET4AI is split into two parts. First, you have the control plane. Just think of this as the brains of the whole system. It's the high-level manager that decides which users participate, where to place that all-important cut for each person, and generally orchestrates the entire AI training job. Then you have the compute plane. If the control plane is the brains, the compute plane is the secure courier. Its job is to handle the actual data transfer between your phone and the server, but to do it anonymously. It enforces privacy rules like K-anonymity, which is really just a fancy way of saying it guarantees your device is hidden in a crowd. The server knows it's talking to someone, but it's impossible to single you out from a group of other users.
Okay, I know this is all a bit abstract, so let's make it concrete. Let's look at a case study to see how this would all play out in the real world.
Imagine a research institute wants to build an AI model to understand blood pressure, and they need data from thousands of volunteers' smartphones to do it. This is a perfect use case, right? You've got highly sensitive data that needs the absolute strongest privacy protections possible.
And this is where the system's flexibility just shines. The NET4AI control plane, the brains, could look at all the volunteers and dynamically sort them. So for Group A, users who explicitly consent to sharing raw data, it assigns a bottom cut. For Group B, most people with modern phones who want a balance of privacy and performance, it assigns a middle cut, good old split learning. And for Group C, maybe users with older phones or those who demand maximum privacy, it assigns a top cut, federated learning. The amazing part is all three groups can participate in the exact same training job, totally seamlessly.
So this is the vision, a pretty powerful one. But what's the road ahead actually look like to build this intelligent 6G network?
The ultimate promise here is a fundamental change in our relationship with technology. I mean, think about it. Instead of us having to constantly fight to protect our data from the network itself would become our active partner in privacy, all while unlocking the potential of these incredibly powerful, collaborative AIs.
And of course, we're not there yet, not by a long shot. There are huge hurdles to overcome. All this distributed computing consumes a ton of battery power on our phones. People's connections are unstable. What happens when a phone just drops out mid-calculation? And simply scheduling the computing and network resources for millions of devices is a mind-bogglingly complex optimization problem. And that's not even mentioning navigating all the global data privacy regulations. Which leaves us with a final big question. We've spent decades building networks to be dumb pipes, just moving data from point A to B as fast as they can. But maybe, just maybe, the future of digital privacy and powerful AI lies in making the network itself intelligent. Is that the path forward? It's definitely something to think about.